All right, so today algebra, we're going to be going over 1.5, which is all about solving inequalities. So today we're going to be talking about some vocab, because vocab is extremely important in math as well as your other classes. An inequality you have seen before, okay? Inequalities indicate that you have a greater than sign, a less than sign, a greater than or equal to sign, or a less than or equal to sign, okay? So you're going to want to know all these words and symbols. So less than, if you have less than something, it's a sideways L. I'll remember it. Less than, sideways L. Greater than is the opposite of that. If you have greater than a certain amount, you have greater than that. Okay, if I were to say up to, you have up to $100. Well, that's actually less than. You have up to $100 to do this. Okay, you can win up to $100. It's going to be less than 100. It could be 99. It could be 98. It does not include that 100. All right. At most, if I say, hey, I will let you borrow at most $100, that's less than or equal to, because I'll let you have that 100. Right? Less than or equal to. If you have at least 2 siblings, that means you can have greater than or equal to. In between. So if I say you can have between 3 and 5 M&Ms, it would be greater than X and greater than sign, or less than X and a less than sign. As long as your symbols are going the same way, that indicates a number can be between two symbols. All right, so between is using that. So now we're going to solve inequalities by graphing solutions and interval notation. So interval notation is going to be new for you guys. So go ahead and highlight that or put a star next to that. It's really big with graphing this year, so we're going to introduce it today. So when you do this, I like to pretend that there's an equal sign instead of the arrow, okay, or the less than an equal to sign. So if this was an equal sign, to solve for x, we would add 5 on both sides. Add 5 on both sides, you get x is less than or equal to 15, all right? So what you're going to do when you go to graph this or sketch this, there's a few things I need to see. I need to see that you have 0 somewhere on there. All right, you need to indicate where 15 is. It does not need to be a perfect graph. All right, and then what you're going to do, you might remember this from 6th grade, is if I have x is less than or equal to 15, this little line underneath indicates that I'm going to have a circle that will be shaded. And any number to the left of 15 is a solution. So you might be saying, okay, Mr. Dursky, well, how do I remember this? Anytime you have a line underneath a greater than sign, so greater than or equal to, or less than or equal to, that will be shaded because it includes that number. X can be less than or equal to 15 for this to be true. Anytime you have a greater than or less than sign, your circle will just be open. So let's try this out. What's a number that is less than 15? Well, let's just say 12. 12 minus 5 is 7. Is 7 less than or equal to 10? Yes, that is true. So my solution is correct. All right. So again, same thing that we've been doing, pretending like there's an equal sign here, but a little different in the fact that now we have to make a circle at our solution, all right, shade it in or leave it open, and indicate which way our arrow goes. So x is less than or equal to 15. Now, interval notation, all right, we know that the solution all the way over here says that, hey, it's going on forever, right? It goes to infinity, negative infinity. So that means for my solution, I'm going to put parentheses, all right, because it goes on forever. Solutions could be anywhere on this graph all the way to negative infinity to, going this way, solutions can be any number all the way to positive 15. And it includes 15, which means if something includes 15, you're going to use this little bracket, all right? So 2 things you need to know is you're going to say basically when it goes all the way to the left, where it hits at the left, here it hits at negative infinity, and 15. Now, anytime you use these brackets, it means that number is included, all right? And these parentheses means that that number is not included, but it's really close to negative infinity, which we'll continue to touch base with in class, okay? Let's try number 2. So let's solve for the variable like we typically would. All right, I'm going to subtract my 2x on both sides. 3x minus 2x, well, that's going to be 1x. I'm going to subtract my 4. You get 1x is greater than negative 3. In other words, x is greater than negative 3. Again, need you to go in, indicate where your 0 is going to be, where your negative 3 is going to be. Is my circle for shading going to be opened or closed? This does not have that line underneath the greater than symbol, so it's just greater than. It's going to be open. And it's greater than, so it's going to the right. Full notation for this one, all right? All the way on the left, it's super close to negative 3, but does not include negative 3. So x does not include negative 3. X has to be greater than negative 3 for this solution to work. All right, and it goes all the way to the right. So it goes to positive infinity. Notice how it does not include, so I used parentheses. I did not use the bracket. The bracket means it includes that number, all right? Number 3. Number 3 is a little tricky, all right? So you always want your variable to be first in the statement. So x is greater than negative 3. If not, it's a little bit complex. So what I like to do is I like to flip everything first. So I'm going to move, x minus 12. Whoa. If you're flipping things in here, you also need to flip the sign. So now I have less than or equal to. I just flip the sign the other way. And 8. All right. When I do that, now I can solve. I can add 12 and add 12. Get x is less than or equal to 20. And the only reason I did that is because if you'll see over here, x isn't on this side, it's on the other side. So I always flip first, and when you flip, you have to flip the sign as well. So go ahead, 0. All right. 20, indicate where 20 is. Open circle or closed? Well, closed. And it's going to go to the left. So it's saying any number less than 20, including 20, will make this statement true. Okay, so let's go ahead and do our interval notation. All the way to the left, it goes to negative infinity. Any number that way will make that statement true. All right, and to the right, it goes to 20, and it hits, so that means it includes 20 in the solution. All right. Number 4. Number 4 is interesting. Okay, so if I subtract 4y and subtract 4y, those cancel. I get negative 1 is less than 11. Well, is that statement true? Is negative 1 less than 11? Yes, negative 1 is less than 11. So any number I plug in for y, okay, will make this statement true, which means all real numbers for this one. All right, I'm going to have you guys try 5 and 6 on your own. Go ahead and freeze and solve those on your own. And then I'm going to go ahead and start number 7. So for number 7, I want you to make a little line here with a note above it. So you know that if you divide by a negative number, to solve, you have to flip the sign. It's just a rule with inequalities that you learned in 6th grade. Just a reminder, if you divide by a negative number to solve, you have to flip the sign. So for this one, for number 7, well, we have negative 3 is greater than negative 15. We have to divide by a negative number, so that means I have to remember to flip my sign. I'm going to do that first just so I remember to do that. Instead of it being greater than, it's now less than. So I'll have x is less than 5. So I'm going to go ahead, indicate my 0, indicate my 5. All right, open or closed? Well, it's going to be open, and it's less than 5, so it's going to go to the left. So any number less than 5 will make this statement true. Interval notation, all right, from the left, negative infinity, okay, up to 5. 5 is not included, so I'm going to do parentheses. It gets close to 5, but 5 is not included. What that means, guys, is any number that's super close to 5 but doesn't touch 5, maybe it's 4.8, will still make this statement true. As long as it's not 5, 5 is not included because it's not shaded, it's getting close to that 5. All right? Let's go ahead and try 8. Distribute 2x plus 6 plus 2. All right, I'm going to bring everything down. I'm going to subtract 7 on both sides. All right, so now I have x is greater than 6 plus 2 is 8 minus 7 is 1. X is greater than 2x plus 1. Well, I'm going to go ahead and subtract 2x. Again, there's multiple ways you can do this. So now I have negative x is greater than 1. Well, I can't have a negative x. I want it to be positive. So if I divide by a negative 1, remember, we have to flip our sign. So x has to be less than negative 1 for this to be true. We have 0. Negative 1. Is my circle going to be open or closed? My circle is going to be open, and it is going to the left. Interval notation for this one, all the way on the left, anything up to negative infinity to negative 1 will make that true. But for that negative 1, we need the parentheses, not a closed bracket, because it does not include negative 1, but it gets super close to negative 1, our solution. All right, let's take a look at 9. For 9, to get x by itself, this is a fraction. I'm going to multiply by the reciprocal, and I want to get rid of that negative sign at the same time. So I'm going to multiply by negative 6 on both sides. That will cancel those out. I am left with x over on this side. Okay, since I multiplied by a negative number, that is the same as dividing by a negative number. So that's going to actually flip my sign to the left. Negative 6 times 3 gives me that negative 18. And what did we talk about before with the variable coming first? I'm actually going to have to flip this. So now I'm going to have x. Okay, so since I'm flipping it so that my variable comes first in my statement, I'm going to have to flip the sign again. So x is greater than or equal to negative 18. All right, indicate where your 0 is. Indicate where your negative 18 is. Is my circle going to be opened or closed? My circle is going to be closed because of that line underneath, greater than or equal to. All right, because of that, all the way on the left, here's negative 18. It's going to be greater than or equal to negative 18. X for that variable is going to be greater than or equal to negative 18. All right, so I know for interval notation, it hits negative 18. It includes that negative 18. All right, it's going all the way to positive infinity. I'm going to do the bracket, not the bracket, sorry, the parentheses there for that one. All right, I'm going to have you guys go ahead and try number 10 on your own. So freeze it, try that on your own. And I'm also going to have you guys try number 11 on your own. All right, so 12 and 13. 12, it says 6 times a number. So I can write that as 6n. Minus 12 is no more than. Well, if I have no more than, it's going to be less than or equal to twice that number. All right, so I should have 6n minus 12 is less than or equal to 2n. Go ahead and solve that one on your own. Actually, we'll do it here. I'm going to add 12 to both sides. Subtract my 2n, subtract 2n. 6n minus 2n gives me 4n. 4n is less than or equal to 12. Am I done? No, I need to divide both sides by 4. You're going to get n is less than or equal to 3. Any number, the largest possible integer that satisfies this statement is any number less than or equal to 3. All right, so if I had to do interval notation for that, any number from negative infinity to 3 with the bracket would be a solution for that problem. This next one, it says 8 minus 4 times a number is at least 16. At least means it's greater than or equal to 16. Solve for that missing number. Well, I can subtract 8. Subtract 8, you get negative 4n is greater than or equal to 8. Divide both sides by negative 4. But remember, if we're dividing by a negative number, what do we need to do? Well, we're going to flip my sign. So I get n is less than or equal to negative 2. All right, interval notation for that one is any number that is less than or equal to negative 2 will make this statement true. So negative infinity to negative 2 with a bracket sign. All right, that's a little bit on 1.5. We'll keep working in class on this. Good job.